Welcome to Networks Professionals.
Welcome back. Let's just dive right into this explainer and tackle what is honestly one of the most critical challenges in enterprise IT today, connecting geographically separated networks. We're going to open up the Network Builder's Toolkit, so to speak, to demystify WAN architectures. We'll be looking at the architectural DNA that allows massive global organizations to operate as if they share the exact same physical floor plan. So, let's get into it. Because think about it, modern organizations are rarely confined to just a single building anymore, right? They're more like these distributed archipelagos, spread across different cities or even entirely different continents. So the grand architectural question we need to answer is, how exactly do we connect the world? How do we build those digital bridges and shipping lanes between isolated locations so they actually operate as one unified, low-latency entity? Section 1. Bridging the distance, the foundation of connectivity. To really answer that, we have to start with the Wide Area Network, or WAN. This is the underlying architecture that basically takes over the second your local area network hits its physical limit. And the goal here isn't just some basic bare-bones connectivity. It is all about seamless data sharing and centralized management. Honestly, whether your data is traveling just across the street or all the way across the Pacific Ocean, a well-designed WAN makes that physical distance completely invisible to the end user. It's like magic. Section 2. The Smart Controller, SD-WAN. Now, SD-WAN, or Software-Defined WAN, is a massive leap forward for us. Instead of relying on rigid, clunky hardware at every single branch office, it completely abstracts network control into software. It's the smart brain of modern networking. Because this brain is virtual, it can make these incredibly intelligent real-time routing decisions across just standard broadband or even cellular connections. I mean, picture a huge retail chain deploying a brand new pop-up store in a matter of hours instead of weeks. That kind of wild agility, that is SD-WAN at work. Section 3, Guaranteed Reliability and Privacy, the VIP lanes. But what about data that absolutely cannot be delayed? When you hear MPLS or multi-protocol label switching, I want you to think of absolute predictability. Service providers use this as a private routing technique to totally lock down the exact path your data takes. By forcing data down these very specific, predetermined paths, MPLS virtually guarantees quality of service. So if you're transmitting live medical imaging or synchronizing rapid-fire banking transactions where a dropped packet is quite literally catastrophic, MPLS is your highly reliable VIP lane. No traffic jams allowed. Now, while MPLS handles private routing, leased lines take performance to the ultimate physical extreme. You're literally renting a dedicated physical point-to-point connection, like dark fiber, straight from a telecom carrier. You're not sharing this line with anyone else. It's your own private highway. This is the absolute gold standard for places like high-frequency trading firms or massive data centers, where guaranteed bandwidth and near-zero latency are just totally non-negotiable. Section 4. Secure and Flexible Reach, the Agile Connectors. Okay, so we've talked about dedicated lines, but what if you need agility over expensive physical infrastructure? A virtual private network, or VPN, is a brilliant workaround to the high cost of those leased lines. By employing complex tunneling and encryption protocols, it essentially carves out a secure pipeline right through the middle of the chaotic public internet wilderness. It's an incredibly secure and remarkably cost-effective method for bringing remote sites into your central network, all while using existing public infrastructure. And this right here really highlights the ultimate trade-off that network builders face every single day. On one hand, you've got MPLS and leased lines offering private routing and dedicated physical paths. That gives you rock-solid quality of service, but definitely at a premium price. Then on the other hand, VPNs rely on public internet routing and encrypted tunneling. You're basically trading those rigid physical guarantees for wild flexibility and extreme cost-effectiveness. Honestly, it's all about choosing the exact right tool for the job. To round out our toolkit, we have to talk about wireless and satellite WAN. Sometimes the geographic reality simply means that cables are entirely out of the question. Or, maybe you just want to avoid the sheer terror of a backhoe accidentally snapping your main fiber line in half. By tapping into 4G and 5G mobile networks or by using satellite uplinks, we can establish really robust connections for temporary construction sites or deeply remote research facilities, literally without a single physical cable touching the ground. Section 5. Designing your network. The vital questions. So now I'm putting you in the driver's seat. If you're designing or upgrading a network, you really have to answer 3 vital questions. First up, how many locations are you actually trying to connect? You've got to determine the physical scale of your operation. Connecting two corporate offices just across town, a point-to-point leased line is perfect for that. But what if you're connecting 500 retail branches globally? Suddenly, the software-defined agility of SD-WAN or a cost-effective VPN becomes highly practical. The pure number of locations dictates the type of bridges you build. The second question, what is the primary type of data being transferred? You must deeply understand your data traffic. If we're just talking about standard web browsing or sending some emails, regular broadband layered with a VPN is totally fine. But if you're transferring highly sensitive databases or running VoIP, where even a tiny bit of jitter completely ruins the call, well, then you need the strict quality of service guarantees of MPLS. Basically, your data sensitivity dictates your network's rigidity. And finally, are your sites in urban, rural, or international locations? Geography is huge here. A dense urban center might have dark fiber just sitting there waiting to be leased, offering you unbelievable speeds. But an international mining operation out in the middle of nowhere, you're absolutely going to be leaning on satellite WAN. So as you look at your own organization's digital landscape, I want to leave you with this final thought. Given the incredible toolkit we've explored today, are you actually using the optimal architecture for your specific needs? Or are you forcing the wrong tool to do a highly specialized job just because it's what you've always done? Definitely something to think about. Thanks for joining me for this explainer, and I'll catch you next time.
Thanks for watching.